These are the audio notes for the Intro to Organic Chemistry for AP Chemistry. And on the first slide, I've included 3 terms to be aware of. When we study organic chemistry, we're talking about carbon chains, long carbon chains. So the first term of a functional group is something that's coming off of that long carbon chain. A term that actually was used early in the year, especially when talking about polarity, is an isomer. It's the same formula but a different structure. And today we're going to be studying alkanes. So if you have time after the notes today, you are going to be working on a reading guide, and it's only going to be focusing on alkanes. Well, an alkane is carbon chains that have single bonds between the carbon atoms. There are some times when those carbons aren't just in a long chain, but instead they're in a ring. That would be referred to as a cycloalkane. So up on the board is an example of a carbon-hydrogen compound. Again, there could be other things coming off of it, but you see a whole bunch of carbons single bond to each other, and again, hydrogen can only single bond, so you see those as well. What we need to do is come up with a way to name such molecules. And that's what my next slide is going to show, so I don't think you have to actually draw this out. The IUPAC naming system is the way to figure out how to name long carbon chains. And the first thing we have to do is identify the longest chain. And what I mean by that, if I go back to the previous slide, the longest carbon chain, if I start here, it's a 1, 2, 3, 4 carbon chain. Or heck, I could start here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. In other words, 4 carbons, no matter how I do it in a row, is the longest chain that's there. Whatever's not part of that longest chain is now a functional group. When we start naming things, we are going to number these with the lowest number for the functional groups. And again, it'll probably make more sense when I show you an example of this. If there's more than one functional group, if there's 2 of the same thing, we have to use the prefix di. If there's 3, tri, 4, tetra. And if there's different types of functional groups, we have to order them in alphabetical order. So if we go back to this problem, at the beginning of the summer, I wanted you to learn a little bit of organic naming. This is where I pause for laughter because most of you ignored it. Okay. A 4 carbon chain would use the prefix of but, B-U-T. And since it's all single bonds, that makes this an alkane. This 4 carbon chain would be called butane. Now, if I take this 4 carbon chain, there's still 1, 2, 3, 4 CH3 groups coming off of that carbon chain. If there's only 1 carbon in the functional group, we'll use the prefix meth, which is on your polyatomic ion sheet. This is a methyl group, a methyl group, a methyl group, a methyl group. Since I have 4 methyl groups, it would be tetramethyl butane. Tetramethyl because I have 4 methyl groups, butane because I also have a 4 carbon chain. Lastly, I'd have to indicate where are these methyl groups located. I have this one and this one located on the 2nd carbon, this one and this one located on the 3rd carbon. So the entire name of this compound is 2233 tetramethyl butane. This question's a little simpler. Step number 1, identify the longest carbon chain. 1, 2, 3, 4, or is it 1, 2, 3, 4? Or is it 1, 2, 3, 4, 1, 2, 3, 4? No matter how we look at it, it's a 4-carbon chain. It means it's going to be a butane. But is the prefix for 4. Now, if I just take this as the 4-carbon chain, I have one methyl group coming off of it. The last thing we have to do then is we have to figure out what numbered carbon is this coming off of. And the rules for that is ID the functional group starting numbering with low numbers. So in other words, don't necessarily call this carbon 1, carbon 2, carbon 3, and carbon 4, because then that would make this 3-methylbutane. We don't have to go left to right. We can number however we need to. So carbon 1 is right here, carbon 2, carbon 3, carbon 4. This is carbon 2, so this is 2-methylbutane. I'm going to give you a second to see if you can figure out what the name of this is, and then I will give you the answer. Again, as I said before, the first one was 2233 tetramethylbutane. Second one was 2-methylbutane, not 3-methyl, because again, we number with the lowest number for the functional group. The last one is actually the exact same thing, 2-methylbutane. Some people are just going to count 1, 2, 3 carbons and say that this is a propane, because prop is the prefix for 3. And then say there's a 2-carbon chain coming off of that, which is an ethyl group. You'll notice up on the top board, I've written the prefixes to help you out today. Eventually those will get erased. However, we cannot call this 2-ethyl propane because we're ignoring the first rule, the longest carbon chain, 1, 2, 3, 4. You always have to identify the longest carbon chain. I've actually drawn small organic molecules. They get a lot larger than this, and because of that, we have a method of drawing these out that doesn't take as long. It's called line angle format, where we're no longer going to draw carbons or hydrogens. Again, I don't think you have to write down this. This is me explaining how this works. The end of each line represents a carbon. Hydrogens are always assumed to be bonded to carbon to get it to the octet if nothing else is bonded to it. Let's go back and look at 2233 tetramethylbutane. If I asked you to draw that out, I would start with the ending part, the butane. I would do a 1, 2, 3, 4 carbon chain. That's butane. So if I ask you to draw butane, this is it. Tetramethyl means there's 4 methyl groups. Where are they located? 2 of them are in the second carbon, 2 of them are in the third. So I put a methyl group, because remember the end of a line is a carbon, a methyl group, a methyl group, a methyl group. I could draw something out and ask you to name it. So if I would draw this out, I would first suggest for you to number the carbons. 1, 2, 3, 4. Again, I won't have the numbers there for you. You will have to number it out. 4-carbon chain means it's a but. There's a methyl group coming off of it on the second carbon. This would have to be 2-methylbutane. So, we did this fairly quick. And in years past, I usually have students use the reading guide first and then we do the notes. But I thought I'd try it a little bit different this year to see if me giving the notes early on would help you in doing the reading guide. A lot of students ask, again, why are we going over this? Well, there's a couple of reasons. One, a lot of college chemistry courses will do some organic chemistry in that first year. We don't have to for the AP Chem test, but they still have to do it sometimes for intro chem in college. Secondly, besides the semester exam that you took last week, you have one more chance to earn points, and that's by doing extra credit with organic. And slowly throughout the course, I'm going to show you what you need to do. But one, and this says, let's try our favorite class. I want to give you a little taste of what you might see when it comes time for your extra credit. Everyone's favorite class in this room is chemistry. We'll call it chem. With these letters, you could try to solve for what is the organic name of each letter. Remember, either looking on your polyatomic ion sheet or up on the board, I have the prefixes for all of those. So this is where I would like you to pause the video, give the students a chance to try to write out the name of all of these parts. If we look at the first carbon, I see 1, 2, 3, 4. I'd call that butane. If I look at the hydrogen, I'll start at the top. 1, 2, 3, 4. So that will be a butane. But I also have a methyl group coming off here and here. 2, 3, dimethyl, sorry that I ran out of room, butane. Some students would say, but can't I just call it 2,3-methyl butane? The di is kind of redundant, and actually I agree with that. However, I was not the one who came up with these naming rules. I'm the one who teaches them, so this is how you have to do it. The E. 1, 2, 3, 4, 5. That's going to be a pentane. And coming off of carbon 3 is a methyl group. 3 methyl pentane. Finally, the M. 1, 2, 3, 4, 5. That's pentane. But come to think of it, your favorite class isn't chem alone. It's AP Chem. Last thing to bring up to finish up notes is notice how the A and the P are not just chains, they're rings. If I look at the A, it's a 1, 2, 3 carbon ring. You call that cyclopropane. Prop is the prefix for 3, cyclo because it's in a ring, ane because it's all single bonded. Notice how there's still 2 methyl groups coming off of that. 1, 2, dimethyl cyclopropane. Give you a second to think of what would the letter P be. Again, I would identify the ring of 4 first, so it's a cyclobutane, and then there's a 1-methyl group on it. As I mentioned before, the reading guide originally was the first thing to do, but my hope is now if you look at your text, it can help you understand how to do this a little bit more going forward. Because in the next class we're going to introduce things with double bonds and things with triple bonds.